now our speaker is our longtime CJUX supporter, Gautam Singh. Thank you and welcome. Gautam is a principal solution architect and an executive technology consultant and founder. He's also an AWS certified solution architect associate. He has over 16 years of total IT experience that includes hands-on and leadership advisory work. He has helped multiple clients in cloud native and microservices migration. So with that, welcome, Gautam, and you have the stage now. So,
thank you, and I like to start with thanking Mary, our amazing host, and just thanks a lot for keeping this active community going. Welcome, all the CJUG member who decided to spend your evening with us. You could be at so many places, so thanks for spending your evening with us. My name is Gautam Singh, and Mary already gave a nice introduction, so I wouldn't spend more time introducing myself. So let's get right into it. Again, I've been doing a lot of work that are not development, but I've always considered myself as a Java developer. And I started developing Java with 1.5, and I had my ifs and flows with Java. Sometimes I feel like it's just too archaic, too enterprisey, and things are not so exciting. But then things started changing. After Java 8 introduced Lambda and Streams, and then around Java 11, I guess, or maybe after 9, once we started following the 6-month release cadence, things started moving really nice. And we are seeing every 6 months new feature coming in, and I'm really excited about this. So yeah, basically a brief, why we should care about Lambda and Streams. It's been there for quite some time. Recently Java 8, it's been 8 years now, since Java 8 was released. But I am still seeing, at least in my experience, developers are not really, adapting Lambda and Streams that I hope, they would, right? And basically, at least one of the, reason is because, a lot of us are so ingrained into imperative programming styles, right? Because when you have to write programming schemes, you have to think in a different style called functional programming style, right? And that is something that is a transition that sometimes is hard. So again, like imperative style, we all probably know about it. It focuses on how things are done. Mostly, you do statements and for loops and conditional blocks. It basically relies on mutation heavily. So you basically change states and maintain states. And again, it relies on assignment, loops, conditions, and sometimes if you're looking at a program, it's easy, especially if you are used to it, to read the program. But as your application get complex, the readability suffers. And also there are other problems with imperative style. One being tightly coupled logic, right? So in this program, you can see this is actually a program that we refactored, and we did an application modernization where we converted our backend from MVC to APIs, and these kind of codes were all over the place. So here you see that there is a method add item to order, and it's doing some validation, and then if there is a validation error, it's adding exception to a form exception, right? And the problem with this approach is with APIs there is no form to add exceptions to, right? So ideally this should have returned a validation error rather than adding it to form exception, and that is a problem that you might see with imperative style code. It's lot of tight coupled logic. Code duplication, again, it's because of the verbose nature of the imperative style. You will see a lot of code duplication, and that is a technical depth. So we should avoid code duplication. Again, poor readability is another issue, as I mentioned. Initially, when you write program, it's easy to read, but once it gets complicated, things are very hard to read, and it also leads to error. And this is one of the biggest problem with imperative style is these code are hard to parallelize. And by parallelize, I mean not concurrent, right? It's basically, if you want to take advantage of multiple core to solve your problem quickly, in imperative style, you have to essentially rewrite the code. With the Streams API, we will see that how easy it is to write parallel code. And this is, again, not talked about a lot, but in my experience, I've seen imperative code is very hard to test. One example is like, we had some test cases basically failing for, sporadically for, sometimes, and sometimes it works. And ultimately what we find out was the test cases only works when they run in some order. And, our test runner were actually basically, running it in random order. So sometime it works, sometime it doesn't. And that was something that, you will have a brittle test, with imperative style, especially if you are not careful. So I hope, you might want to try out different approach, and let's look at how functional programming is different from imperative. So again, it focuses more on what instead of how. And when I say that, it doesn't mean that you don't have to think about how. Obviously, you have to, write the logic, but you decompose your problem into a smaller problem, and you write composable function, and hopefully those functions are pure functions without side effect, and not relying on mutation. In that case, that function is basically a unit that you don't care about necessarily what it is doing. All you care about is this function, when I'm going to call, it is going to return me this. Yes. And again, it promotes mutability, which is the enabler which helps us, parallelize a problem, and also it, reduces the unnecessary, errors in your code as well. Function is a first-class value. What I mean by that is, the function can be assigned to a variable. A function can be passed as an argument to another function, and function can be returned from the other function. This is, again, it uses expression over statement. So in this one, you are basically, creating an array list and assigning it to a variable. That is a statement. And the other one basically is you are calling a function and passing it another function, which is an expression. And lazy evaluation is another benefit that you get from functional programming, because your code has no side effect, or at least minimal side effect. If we are not necessarily having a pure functions, then you can actually do like short circuiting. In case you don't have to perform certain operation, you can short circuit that operation and also do lazy evaluation, and we will see that with example. Any question before we jump into Lambda? Okay, I see there is something in the chat. Okay, let's look at Lambda then. Sorry.
Yeah, one. Can you hear me?
Yeah.
Okay. In the previous screen, right, the list for each, right, you put system.out, right?
Yeah.
Is there a way can we use log4j logging there, logging frame SLF4j like through that, like that system.out.print instead of that.
Yes, so you could like the question I believe is instead of system.out.println, can we do like log.info or log.debug, something like that, right?
Yes, exactly.
Yes, and you can do it, and you should do it. Again, like system.out.print is only for debugging purpose, and ideally you shouldn't check in your code with that. But yes, you're right. You could do anything. This is basically a method reference syntax, the two colons. So you can have like let's say if you have you are using Lombok, you'll have an instance of your log as a log variable, and then you can do log : debug. Does that answer your question?
Yes, thank you.
Okay.
Thanks.
Okay, so yeah, let's talk about Lambda. So Lambda is basically what enables in Java to do functional programming. What is Lambda in Java? Again, Lambda, how it is implemented rather, is it's a concise and a convenient way of defining anonymous class for functional interface. When I say, I literally doesn't mean that that is how Java is implemented, because if you look at the bytecode, actually the Lambda function is implemented as a static static method. But typically, what you would have done prior to JDK8 as an anonymous class can now be done, through Lambda expression. If the interface that you are implementing is functional interface. And what is functional interface? Again, this is interface with one abstract method. With Java, again, we can have default methods. So a functional interface can have one or more default methods. It can have one or more static methods. And optionally, it can be annotated with functional interface, but that's not necessary. The compiler is smart enough to know if an interface is functional interface. In Java 8, we have there were some interfaces, functional interfaces that were introduced. One is function, which has one method apply, which accepts a generic type T and returns generic type R. Predicate is again very commonly used functional interface. One abstract method test accept one argument of type T, generic type T, and returns a Boolean. Consumer accept method, and it is basically used for consuming something without returning something. So if you just want to maybe print out into the log or something, you can use consumer for that. And there are different other variations of consumer as well, like by consumer, which accepts 2 arguments instead of 1. Then you have supplier. Again, it is to supply a value, and the method is get. There were some interfaces that were present prior to Java 8, like callable and runnable. Those were also basically now a functional interfaces. Then this is custom interface. So it has one default method. So again, only one abstract method. So it is a functional interface. This one is a little tricky. It's a comparator interface. It has 2 abstract method, but equals method is implicitly inherited from the object class. So again, it's not considered, and comparator is still a functional interface. And there is a interesting story about that. This equal method is only added for its Java doc. So again, before we dive into code, any questions? Okay. So just set some context. Is Eclipse visible? Okay, I'm assuming it is. Let me see. Is it big enough for everyone?
I think if you can increase,
yeah, maybe open something,
bit,
right?
yeah, have the fonts a little bigger would be better.
Okay.
Yeah, it should be good for me.
Okay.
Yeah.
Okay. So again, just to give some overview of the workspace, we have these models object, domain object, and in here, then we have these repositories, which are nothing but basically they are reading from these file and returning some values, and then we have some business classes like services classes where we have different business implementation. So we'll look at this one first. Okay, so this one again, this is basically all these examples are catered to a conference organizer, and so you'll see like attendee, host, and all those things. So in this one, as a conference organizer, you would like to print out, let's say, a list of all the attendees based on their last name, so sorted by their last name. And this is typically how you would have written the code in Java 7 or earlier. So you would have an anonymous class, and you implement the compare method, and all you care about is basically this, right? So what you are comparing based on, right? So this is the whole logic is this, which you really care about, but these are all boilerplate that you had to write before Java 8 or before Lambda. So now let's see how we can make this concise, right? So here this is the Lambda operator. So we just converted this into Lambda and removed the boilerplate, right? So if we run it, it still runs. And it print out, so you would see the last name, A, and then followed by last name Young. So this is much better than what we had earlier, right? But is it good enough? Probably not, right? So we still have a lot of boilerplate, right? So what if we remove the type, right? Now it still works, right? And the idea here is called type inference, right? So because when you are writing Lambda, you are writing it in a context, and the compiler understand which context you are writing in. Here you are basically calling the Lambda on a list of attendees. So attendee is implied by that. And also, you can remove the curly braces and return if you only have one statement, and that is what you're returning. So in that case, all you need is this. So again, we were able to, change like maybe 5-6 lines of code into one line, right? So that is the advantage of Lambda. Again, we can, in this case, there are a lot of method that you will see in Comparator and even other interfaces that you could use to write more concise code. In this case, right here, all we care about is attendee last name, right? So here now we use, instead of Lambda, we use method reference, which is again a syntactic sugar on top of Lambda. So this could be, you could have actually just used the same thing here. But we just converted this. Actually, we don't need 2 parameter because all we need is the last name. So comparing takes, it only needs to know which attribute is used for comparing, right? So this is all you need, but we can use the method reference. Okay, any question? And let's run it. And it still work. So the last name here is Acosta, Alfred. Okay. Okay, so let's get back to slide and talk about streams. So streams is basically a set of API that enables us to do Lambda programming, right? And how do you define stream, right? It is basically a way in Java to process sequence of data in more declarative way. So stream is nothing but a set of APIs, and it doesn't store data. It rather kind of iterate, you can say, data, and you can do some processing by using stream APIs. And the data source can still be a collection. It could be a IO resource like file stream, and basically you can perform different operations like map, filter, aggregate operations, and we'll see with examples. So how stream data processing usually work? You again have a stream, like you can get it from one of the data sources, and then you can do like filter. So you will use predicate to filter your data set into maybe a smaller data set, and then you can call mapping. So maybe you have an object and you only care about a field of the object, so you can map it to a field. And then you can also perform different operations like sorted to have it in a different order. And then finally you call collect or some other terminal operator. So these are basically called intermediate operator: the filter, the map, the sorted, and what it gives you is another stream, right? So when you call filter, you get a stream again. When you call map, you get a stream again. And again, when you collect, you basically can collect it in anything. You can either call a method like you can collect it in a collection. You can have like one element, maybe truncate everything into a string. So there are different variation of collect that we'll see. How do you create stream? Again, streams can be created from a data source. So you will call, for instance, in this case, we are having an attendee list, and we call .stream on that to get the stream. You can also have your stream created from an array. So you have an array, you can specify from which to which you want to include and pass the array here. Or you can also have streams of and pass the individual element of the array. You can also get it from files. So like if you call file.line, what you'll get is basically, and it takes a path of the file as parameter. What you essentially get is all the lines within that file as a stream. So why should I use stream, right? So stream has a rich API. It has works well with Lambda, so it is very concise. It is immutable. Again, you could do mutation with streams as well. So necessarily, it's not always immutable, but it actually supports immutability and promotes immutability. Lazy evaluated. So again, we will see with example how sometime it is not going to process everything, rather, get the result by, evaluating whatever is needed. It is null safe. So whenever you are calling an API, you would you rather get optional. If it's you could get empty optional, or you could get another stream, which again can be a empty stream. So sorry. So let's now again look at code. Any question? Okay. So let's look at the stream exercise here. So again, this one is, again, we have attendees, and we are interested in knowing the average first name length. Again, it's a silly problem, but let's look at how you'll solve in imperative style. So here we will basically just initialize, a variable with 0, then loop through it, add, the length of the first name, and then finally, we divide it by the size and get the result, right? So that's fairly standard. How would you do it with streams? So again, the first thing you would do is you would get the streams object. Again, if you are writing code, you are assuming here that this is not null. And if you, have a method where you can get null value, then you have to do a null check. And then we are only interested in the first name, right? So we will basically call map and pass the lambda. So now what we get is a stream of string, right? So here we had streams of attendees. Now we have streams of int. Now we call, we are also interested in the length of, first name, nothing else, right? So we can call map, not attendees. This is string, so okay, I don't know why autocomplete is not working here. So we'll say string.length. So now we get integer, right? So again, we don't want to do auto boxing here, so you can do a map int, right? And this will give you, I think, map to int, sorry. So this will now give you int stream. You would see this, all over the place. So basically, because Java is not like a pure object-oriented programming, you also have primitives. So for primitives, it has, Java has provided you primitive streams as well. And then finally, we can call average is another stream method. This will return optional double. So what we do is we would say get get as double, and that's all, right? So if you and then we return this. So now, this code, if you see, it reads very, you can easily understand what it is doing. So, and it reads better, right? So versus what we have before, you have to really look into the implementation to understand what it is doing. Versus here, you basically, know that, we are getting stream, mapping it to first name, mapping it to the length of the first name, then averaging it out, and then getting the double, right? So it reads better. Again, there is different ways to solve this. You could also use MapReduce here. So you could call, reduce and, get the So let's first run this. Let's make sure that we are getting some value. And yeah, we got this average here. And we would like to just make sure that, we are not cooking out any value. So we'll run the initial program. And we got the same value, right? So so here we are. So we can also do reduce, operation. And again, reduce is basically it requires identity value. So we pass it 0. This is actually more closer to what we had before, right? So and then you would pass a value of basically what you'll say is you have 2 values. How are you going to combine them, right? So you will say A plus B. And I think it doesn't like this. And then we get this. I think we already get the value here, so we can just now do attendees dot size. So this is what essentially we were doing earlier. And now if we run it, we get 5, right? Why do we get 5? Because we are dividing integer by integer. So by default, it is actually converting it into integer. So now we just basically cast it to double. And we will get our result here. Any question?
Yes, Gautam, hey, this is Keel. I had a question about this reduce operation. Can you clarify what exactly it does?
So reduce is basically you have a sequence of values and you want to reduce it to one value, right? So the way it works is you basically provide identity value, so where to begin with, right? And then you provide a combiner, right? How you will combine 2 values. So essentially what it will do is like, let's say you have value 1, 2, 3, 4, right? And then the reduce, the way it works is it will get, first say, okay, I'll start with 0. Now I read value 1. How am I going to combine it? So I'll say I'll get 0 and I'll get 1. I will combine it by, doing 0 plus 1. So I get, 1 here, right? Now my value is 1. And I get next value here. I read the next value 2. And, I'll say, now I have 2. How am I going to combine it? So I'll basically do, 1 plus 2. Again, it's like, so I got 3, right? So that way it's going to reduce the sequence of value into one value.
Okay. Okay, got it. Can you show what the first arguments says about this reduce operation? I wasn't able to read it.
Oh, okay. So let's go here. So yeah, the first one is basically your identity, and this is the value where it will begin the processing.
Okay. Okay, got it.
Yeah.
Okay,
and again, this is because we have int stream here, right? So you have this reduce. If you are having like streams, then you can essentially do reduce operation on any data type. It's not limited to like a numeric data type alone.
Okay.
Gautam, one question. So what was the old implementation it would be before Java 8 for the same functionality? Do we have
Yeah, so that's what we started with, right? So when we begin with, this was how we implemented it, right? So again, all the example I already have the code written in imperative style, prior to Java 8. Make sense?
Yeah, Gautam. So here with this old style before Java 8, as far as I can see, in the heap, we will create in the stack trace, we will create only one local reference, which is basically this local variable total length. Then we will add this length of first names. But with streams, how does it work in the heap or in the stack?
Yeah, so that's like, again, as I said, right, stream is not a data store, right? It is essentially doing the same thing. It's just basically a rich set of API that helps you, do things more easily, right? So if we go back to here, this. So here, right? So basically what you are doing is like, it is going over one item at a time, right? So you get a stream of attendees, then it, gets the name from that, then it gets the length of the name from that, and then it, gets this, it is doing the reduction, right? Again, it's not actually storing anything. It's all, happening locally, right? It's basically, doing the processing and, using, that's kind of internal how it does it. But, it's using maybe a local variable, for like, for instance, map, right? It doesn't have to actually store anything, right? It's not a stateful method, right? All you need to care about is from this object, I'm interested in the first name. So it doesn't even need to store any, anything into any local variable. And then from here, I'm all interested in, I have a first name, all I care about is the length of the first name. So I think we are kind of, getting over time, maybe, if time permits, we can, take it further. Sounds good?
Yeah, okay, yeah.
Okay.
That was helpful,
What do
thank you.
the A and B represent?
Yeah, so here A and B represents basically the value, like, when I had this right here, right? I think I removed it, but when you are going through it, right? So you get, you start with 0, and then you get 0 and 1 here, and you will, get a value of 3. Sorry, my maths is horrible. You get a value of 1, right? 0 plus 1. Now you have 1, and so your A and B would be 1, and then the next value is 2, so you get 2, right? So that's how, that is what A and B is.
So A is the result, and you've initialized it to 0, and B is just the number in the stream that's being sent to you from length. Yes,
right. So A is essentially, what you can say is A is nothing but this thing. What you have in imperative style.
Might be helpful if you just create a new method, like get average first name length 2.
Yes, right.
So we could compare. Thank you.
So Gautam, the first value is the index of that element in that list. Is it correct?
Not the index. The first value is the current
That one.
computational value, right?
No, not that one. The 0, the first 0.
The 0 is not the index. It's basically the identity value. So like, let's say, you are processing a sequence of data where you want to start, right? You can say, if you are adding, length, then you start with 0, right? So this is the initial value, the seed value. Okay, so let's look at another problem. So we saw this problem, right, and we solved it, but there is an issue with this code still, and we'll look at it. So let me run it in debug mode. So here we went to this repository, and there is this cached attendee, right? So what it is doing is it's actually reading it from the file and then caching it here, right? So if you see right now, we have this, Kashim Fisher as the first element, and then we have the list, right? And so let's now come out of this. Let me make sure that we have a breakpoint here. Okay. So now we, call this method, and we came here. Now, if you go back and look at the cached attendee, what is that? Okay, I don't know why is it not printing it. Let's use here. Okay. This is interesting. Let's just call it then. Okay. Oh, awesome. Okay, so now you see that the element actually changed. Now we have the sorted list as the cached attendee, which was unintentional, right? We didn't want it to actually change anything in the repository. All we wanted was to sort it, in this program, right? So the original, item may be sorted by the creation date, and the other client might still want to have it, by creation date. So again, that is the problem of mutation, right? So how do we solve using stream? Oops. So let's look at this. So again, we will say stream, and then we will call sorted. And so this one is going to return you a stream of sorted, sorted attendees. So, and this you can actually call toList to get the list. So now, what we did is we use Streams API, then we call sorted to get the sorted list, sorted stream, and then we call toList to get it. Now let's run this program again. Again, let it go. And let's come back here. Oops, I think I went too fast. So again, if we see here, it is again, this Kashim Fisher is the first element. Now I am going to add a breakpoint here again, move it here. This should actually give a value. I'm not sure why. Oh, here, now it's working. Now you see that this value didn't change, right? Because stream doesn't actually, alter the data source. It just iterate through it, and then, it doesn't change anything, with the original data. But you still get the, the sorted list. So, we still have this sorted based on the last name. Again, this toList is a new API. I think it was added in Java 16 or 14. So if you have, you are using any prior version, then you can use collect. And then collect is actually, there are different versions, but one which is widely used is this one, where you pass the supplier. It is more like the reduce method we saw. So here, you pass the initial value as supplier, then you have the accumulator. So basically, how you are going to accumulate the sequence of values. And then this one is combiner, which is used for parallel streams. So if you have parallel streams, ultimately, you will break it down, the data into different chunks, parallelly execute them, and then join them. And the combiner is what is used for joining. So basically what we'll do is in here, we will say, array list new. This is again a method reference for constructor. So you are calling the constructor to provide the initial value. Then you do add. And this is the combiner, and then the accumulator, and then the combiner is add all. Sometimes it makes it easier to write it, right? So array new is pretty clear, but this one is basically nothing but you have a list and you have an element, and Mary, what is the time that we have? I forgot.
You can talk for a while. I think you started at 20 minutes past the hour, 15 minutes. Yeah, it's only not even 8. So yeah, we can keep going. Yeah. Okay.
So basically, you are adding it to the list, and then here also, you have basically 2 lists, and you are combining those 2 lists. So you are basically going to call add all operation. Any question? And let's run it again. Okay, so it still works. Okay, so now let me make sure. Okay, so let's now go to slide again and talk about parallel stream. So as I mentioned earlier, right, the code for parallel stream is no different, like at least not substantially different than a sequential, program. And so how do you create a parallel stream? Basically, you'll, instead of calling like stream method on the collection, you'll call parallel stream. And again, for all data sources, you have variation of parallel stream method. You can also call stream.parallel. So if you have like a sequential stream and you want to parallelize it, you can call parallel method, which will give you a parallel stream. And opposite to that, if you have a parallel stream and you want to get a sequential stream, you can call sequential method, and that will give you sequence. That comes handy if you have like a bigger problem that you have break it down into smaller problem, but part of the problem cannot be parallelized. It's inherently sequential. Then you would like to basically use sequential method to make it sequential and then run that operation, and then again you can do parallel, and subsequently you can again run your programming parallel. So again, this one we is one example where we want to parallelly process it. You just call stream.parallel. You could just have called it parallel stream, but this is another way to do it. Again, talking about how it's implemented, the parallel stream uses a fork join pool. And fork join pool is not new. It was added in Java 7. And it is basically a multi-threading pool to leverage your multi-core in your machine. And the number of threads is dependent on the processors and is basically calculated using this API. Excuse me. But there is a way to change the pool size. So you can pass this argument to change your pool size. And for any serious program, you would like to consider using your own thread pool rather than using the default fork join pool, because that is actually a shared pool. So you could have weights because of something else not related to your problem space. Again, that is not scope of this talk, but this is something to know. Does parallel always mean faster? And the answer is no. Parallel is might do more work. It's actually always do more work if you see in a way that you are basically breaking it down, your problem into multiple problem. Maybe you are breaking your data set into subset, and then you are going to combine them, right? So that is additional step, right? Which you may not have to do if you have done it sequentially, right? So you have always extra tasks. But the benefit is you can parallelly do things, and if the trade-off, like if the time saved is greater than extra time taken to combine the result, then you can surely parallelize it. It makes sense for a large data set. Again, if you have maybe 50, 100, 200 records, don't bother, use sequential. Means the rule of thumb I typically follow is, I start with sequential stream, and if I see, performance issue, then I would, only consider parallel stream. It works better with certain data sets. So if you have, for instance, array list, that works great. If you have a sorted, data set like hash set and tree set, you could sometimes parallelize it, but it's hard, and the linked list and all, this is inherently sequential data. So you cannot, basically parallelize a linked list. Work best with certain operation. Again, the some of the operation we already saw, like filter map. It works great. With sorted, distinct, you cannot parallelize it. It means you can parallelize it, but it's not going to give you, a performance gain. So now let's look at parallel streams in action. Any question?
Yeah, I have one question.
Yeah.
So in the example where you used a sequential and parallel together, right?
Mm-hmm.
Now, what is the purpose of using sequential there?
That's
slowing.
Yeah, that's basically unnecessary. We could it's probably I have it old slide. So this parallel stream was added later. I think I may not have changed it. But yes, you're right. It's unnecessarily, and again, I don't know what is the overhead of creating a stream. I think it's very minimal, so you might not actually see any difference in terms of performance or anything. But yeah, it's just unnecessary.
No, what about that? 1 minute. If you go back there, that's after filtering, you used a sequential as well, right? That is also unnecessary, right?
Oh yes, actually that's necessary. The reason why I've done it is means it's basically the limit operation is short circuit operation, right? So basically, when you say limit, right, it is not going to read after 10th element. So this is one example where you would want sequential before limit, because otherwise what you would do is basically you would process more element unnecessarily. So yes, this is because of you need that sequential there. I can actually show that example. So let's look at, let's start with that example. So we have this attendees, right? And let's write another program. So, but I think I have it here somewhere. Yeah, this is the one. Okay. So basically now we have another problem. The hotel wants, like we have as a organizer, we would like to do a drinks party at the end, and we invite everyone, but the hotel has a rule that if someone is not drinking, and if there are more than X number of people who are not drinking, then you have to book a lobby for them, or a separate space for them. They cannot hang around in the bar. So for that you have to basically find out all the attendees, poor guys who are less than 21 year age, and you would filter them out, right? And we want to know if the count is, let's say 10. That's what the number is. If it's less than 10, then they can hang around in the bar. They just can't drink. So basically we can run this, and we'll see how it works. Oops. Oh, I think I have a compilation issue here. Okay, so now we saw that it processes everything, right? So we can maybe paste it here. And we see that it processes all the 174 element, though all we care about is, whether it was more than 10 or not, right? So in this case, we can use the limit, and we will say limit only 11, and then we do a count on that, right? So now when we run this, we see only 11 elements here, right? So it stops at 11. And it doesn't bother, looking later. So again, that's what I said. It is a short circuit operation, right? So now let's say we call a parallel stream here, right? And run it. And again, we see that even though we are using limit, it still processes. It didn't process the whole thing. If you see it, there were like 174 elements, right? In the beginning, 174, right? It didn't process everything, but it still processes more than which was needed, right? Which was only 11 element. So that is where the sequential can come in, right? So we can say sequential again. And now if we run it, now we see it only got 11. So this is a good example why you sometimes have to use sequential stream, and also why parallel stream may not always be a good idea. Any questions?
Yes, I have one question. Can you go back to the code, please?
Yes.
So this peak operation, is it an operation that is a mix of map and something else? Because peep, I think, takes data and returns it in the same way.
Yeah, it's basically used for usually debugging. So essentially, it gives you a opportunity to, peek into the elements that the stream is processing. So you can do like it accepts a consumer. So, you can do anything with that, right? So here I'm just, printing it in the log, but essentially you can do anything here. And again, it is used for, for debug purpose. Peak may not be called. So we have to be very, careful about the use of peak, So sometimes, you might expect, if you have like peak and you are expecting it to always print the element, if you have a stream that short-circuited, your operation for whatever reason, the peak will not be called. So, just to keep in mind.
Question, please.
Mm-hmm.
Would it be, if I tried to sort a parallel stream, would that work? Would it throw an exception? Would it implicitly convert it into a sequential stream?
It's a good question. I think it will work. Definitely it will work, but yeah, I'm not sure whether it will convert it into, I think it depends on the data structure. If the data structure is like a sorted set already, and you are maybe sorting it based on a different attribute, it might be able to still, parallelly process it. But if you have a data structure that is inherently, again, it's, a fair answer is, I don't know.
Thank you.
Mm-hmm. Okay. So
I had one question. So in this parallel streams and all that, is there a easy way to debug if we have some issue? Like, is any plugin you could suggest, or
not necessarily a plugin, but yeah, means you could actually. So yeah, let's look at that. So you have an element, and then you can print. So here, let's say, we use markers. And so the first parameter I'm interested in is thread. Oops. And then the second parameter is the value that I'm getting. So if I run this here, so let's remove the sequential first, just to. So now if you see it, we know like it is like, which thread it is running. So the first, element was processed by the main thread. Then it uses the worker 2 thread. Then it uses the worker 3 thread, and so on, right? So you can actually do like, you can use again peak operation and do, all kinds of things. In this case, I'm doing is printing the current thread. But if you have, if you have, some other values that you want to look at, you could pretty much do that. And anyway, like if you are actually, using parallel streams, it's not a good idea to use state, any type of state, if you are going to use the parallelization is going to be difficult. So try to avoid, state and mutation as well. Does that answer your question?
Yeah. So, but in general, like even if we don't use parallel, but just for stream, like if we are not printing out, like you have that thread dot current thread, and in the debug window with the breakpoint, we want to get to maybe find out an issue with the code.
Yeah, so debug and all works the same way, right? It's not going to, like, if you add a breakpoint, even though you use parallel stream, it's going to stop, right? So
yeah, it's just that I think being a combined code, it makes it difficult to trace down, or because earlier with imperative coding, we had each line of code separated, right?
I think you can put that lambda into a function.
yeah, I think in IDEA, it actually
it will stop there.
So sorry, I spoke over you. Can you repeat?
No, I was just saying, like, if you really want to, if you think that the code is complicated enough that you need to debug that, right? This is a very simple one, so it may not need. But if it is complicated enough, then maybe you can move that lambda into another static method. Returning a consumer or whatever is required over there, right? A function or a consumer.
Oh yeah, that's a good point, right? So like this one, right?
Like that.
Yeah, you could actually just write a log function here, right? So maybe I can just say, so this one, I can call this log function instead of, and let me just auto-generate this. Oops. Why is it not liking it? Yeah, basically, again, I can just implement it here.
I think her point was that it will be difficult to put a breakpoint when the code is written in this fashion.
Yeah, it's actually not, but again, let's digress it, and let's look at this in debug mode, right? So when we again, that's why it is important to write your code I think, sorry, I didn't catch your name, but, you gave a very good point here. Like, it's not a good idea to, like, these are very simple programs, right? So I am using Lambda here, but it's typically, if you are solving a complex problem, always use method and use method references, right? So that way you can actually set up a breakpoint within the method. But even in this case, right, you can actually see it stopped here, right? So it still works. Again, I've heard that IntelliJ has better support for debugging, but I haven't actually tried it, so I'm not sure. But I've heard from some of my colleagues that IntelliJ has better debugging support for lambdas and streams. But yeah, even in Eclipse, as long as you don't write your code in a single line, it still works. Okay.
Okay, thank you.
Okay, so now let's move to records. So a record is a new addition. It has came out, from an experimental feature in Java 16, and now you can use it. And this is one of my, favorite feature recently. Again, it reduces a lot of boilerplate. What record essentially is, it's a named tuple, right? So in Java, it's an object-oriented language. So, the way it is implemented is as a nominal tuple. It is a plain aggregator of data. So you can see it as a data, the whole data and nothing but the data. It's new kind of class. So if you see the syntax, it resembles a lot with enum syntax. The way enums, all the enums extend, enum class, same way, all the record extend java.lang.record class. And records are always immutable and final. So you cannot extend a record. You cannot actually, create a field which is not final. Oops, I don't know why it came again. And yeah, so this one is, again, this is how you typically declare a record. So you have, you say public, then record keyword, point, and then you have all these fields here. And we'll look at, how it works. So what is record? What is not a record, right? Java beans, records are not Java beans. They doesn't comply the Java beans specification. They are not mutable, right? So if you need a mutable data structure, don't use record. It is, at least for now, you cannot actually use record as an entity bean. There are some workaround, using query, Hibernate query, you could actually use a record, but again, at least right now, the ORM space has not actually adopted the record, and so has other libraries too. So yeah, just to be careful, before adapting it everywhere. Replacement of Lombok, again, it only solves, kind of a subset of problem that Lombok is solving, but Lombok is still very relevant, at least in my opinion. So if you are using Lombok and if you like Lombok, keep using it. And you cannot extend another class. I already talked about it. So let's look at record in action. So we have this point object. So you can see that it is, like any other object model, you have the constructor, all args constructor, then you have some accessor, and we have these hash code equals and toString method, right? So you could actually use Lombok to create it in a smaller, with smaller lines of code, but let's look at how you'll do it in records. So all we need is the fields. And here. So that's all we need. If we I don't know. So here you see, it's record. It doesn't show the accessor, but we can look at it. So now you have record. You could actually define a constructor, your own constructor here. So record uses a compact constructor syntax, so you don't need essentially argument because it is again inferred. And you can write some logic here. So let's say if for some reason you don't want to look into the negative x coordinate and negative y coordinate, you can say x is less than 0, then or y is less than 0, then throw a new illegal state exception. Oops. What is this? Oh, what is this? This is interesting. Am I doing something wrong? Okay, so yeah, means you can actually define a constructor using the compact constructor syntax. You can also have a static method. So, you can have like maybe a static method. And again, for just, fun, I'll just say dot class. Okay, so this, oops. So yeah, you can have a static method here. You can even have a static field. So you could have like static, G. And this works. You cannot have any non-static field. So you cannot define this. It will give you error. And you can also cannot have a non-static, method. Now let's look at this one here. Oops. So, and yeah, the other thing is it can also extend another, implement an interface. So you can say, point is a, instant implementation of a shape. Probably not true, but, mathematically probably not true, but we'll do it here. And then, let's look at this one. So here we can say, let's say, we have a point object, we can have like maybe multiple shapes, and we can, this one is a pattern matching, which is again a new feature in Java. So you can see instead of here and then initializing it here, you can actually do point here. And so this works. So basically, this is a pattern matching syntax. You can even use it with switch expression. I think Java 19 now you are going to actually get even more support for record, so you can actually do something like var x and var y. Again, I just declare it var, but you could also declare it double x and y, and then you can directly use x and y here. So you can just say return x. Again, I am using Java 17, so this feature is not available in Java 17, but in Java 19, you could actually do something like this. And so I like to conclude. Sorry, actually, before concluding, any question?
Equals and hash, we can still do that, overriding.
Actually, record gives you the implementation of canonical implementation of the equals and hash code method. So yeah, that you get it. So if you like say here, oops, let's say you could actually call point what here. So here you see the equals method is available, and if you like, let's say do this and you call this should return true.
Okay.
Any other question?
Yes, so basically record is a final immutable class with data annotation, Lombok's data annotation.
Yes, and it is actually a great candidate for your data carrier. I have one other, I think, one other class. I think I had it used as, this one. Let me see if I have it. I don't have time to actually go. What I was, sometimes you need a convenient data carrier, right? And you want to declare it as a local, maybe class, and you don't have to expose it outside. Great candidate, for that use case.
I have a question. Back to functional programming.
Mm-hmm.
How do you handle exceptions in Lambda?
So in Lambda, you could actually, use a wrapper, right? So you could, instead of calling, instead of, throwing an exception from Lambda, you rather wrap it into, an object and return it. So that is, one way to handle it. Again, the Lambda, you cannot actually throw exception, except if it's a runtime exception. So you could also wrap it into runtime exception and then have the caller handle it as well.
Do you have an example?
Unfortunately, I don't have an
example. I don't actually understand what you said. I have a vaguely understanding what you're trying to say, but the example. Okay, what other options do you have for handling exceptions instead of wrapper?
If let's say you are actually invoking a method where you don't have control, then I think using the runtime exception is alternative, right? And then what you can do is you can wrap. Let's say you are calling a library, function that returns IO exception. Then you can wrap it into a runtime exception and then have it handled by your caller, right? So that is again another approach. But yeah,
why would you use the runtime exception?
Sorry,
why would you use the runtime exception approach? What's the benefit?
It's not about the benefit. It's about the limitation of the Lambda that you cannot actually throw a non-runtime exception. So the way to handle it is to have, again, I'm not saying to wrap it into a runtime exception. Rather, you basically create a custom runtime exception, then you handle it, in your calling code. So in your, main method where you are calling the client method.
Do you have any Java libraries that already handle that exception throwing from Lambda?
I am not sure about that.
What about try?
What about try what?
Yeah, that's the name of the library that handles the exceptions for you. Are you familiar with completable future?
Yes.
Okay, the same approach when they call exceptionally, right?
Mm-hmm.
Yeah, exactly. It's an API base. So that's another option, right? Use the library that encapsulated that functionality for you. I
haven't tried try. So
yeah, right. Yeah. I agree. Another option would be to create. You lost me that object, but what I used the wrapper method. But instead of from the method that throws the exception, and then when you call it in Lambda, you have a problem, right?
Yeah.
You create another option that throws this exception, but internally in that method, handle it. So when you call it in Lambda, you don't need to worry about throwing exceptions because it will be handled. Little optimization is still ugly, but works. Another would be, probably runtime exception is okay, but depends on your case scenario, right?
Yeah.
Check exception has its own merit. Another option
I'll definitely give try.
I have another option for you. just feel like finish.
Yeah.
Another option would be not to throw the exception from your API, and may be called the optional. And I'm a little bit disappointed that you didn't mention optional in your functional programming. You jump to records, but has nothing to do with actually functional that much. But the optional has very nice stream and still belongs to the functional programming in Java. But anyway, that's a choice.
Yeah, that is what I meant when I say, you can actually wrap it into, an object, right? So basically,
well,
you
just call it optional. It would be nice.
Yeah, means again, optional may not be always a great fit, right? If you are returning something else, right, then you cannot return optional, right? So, yeah, but yeah, means I get your point.
Yeah. All right, thanks.
Okay, so yeah, I think that's all. Again, these are great tools, but I think that every tool has its own merits and demerits. So choose your tool wisely. Thank you.
Thank you, Gautam. Thank you for answering the questions. Lots of questions. So thank you, everyone. Are there any more questions for Gautam?
Gautam, one final question. This stream and records API, if we look at the bytecode, does it look same as previous approach for streams? So that's basic for loop. For records, it's final class immutable with annotation from Lombok.
Yeah, so for records, it would be different because, record is, if you look at the bytecode, you can do a Java P, and look at the bytecode, you can actually see that it is basically subclass of record, java.lang.record. And, other things are pretty much, standard. So you would see like, the fields, you will see the accessor and all. And then, the hash code equals and toString method.
Okay, got it. Yeah, thanks a lot, Gautam.
Okay, thank you.
We're good, right? Okay, great. Thank you. I'm sure too, Gautam, you have your contact information. If anybody wants to ask question, they can get on the, if you go on Discord or just go on the meetup.com page too, you can also send Gautam your messages too. So
yeah, great. Feel free.
Yeah, okay, cool.